vector and parametric equations of a plane. We've done a line. So in order to get the equation of a line, you need a point on the line and you need a direction vector. That's it. We did that yesterday. We have vector, we have parametric, and we also had the Cartesian form of the equation if it's in two space, not in three space. We're going to talk about Cartesian form, but for a plane, we'll get to that as well. So we're going to look at vector and parametric equations of a plane now. Plane, of course, is a flat surface in three space, right? So how do I define a plane? Well, I can do it by one of four ways. I can give you a line or a point that's not on that line. So as long as the point is not on the line, I can actually define a plane. So just think of a line going through three space and some other point that is not on that line. You can actually create a plane, a flat surface from combining those two things. Okay. And of course, we know how to create a line already in three space. That's something we did yesterday. The other way that you could create a plane is by giving three non-collinear points. So if I give you 3 points, then if I only give you 2, then you can create a line, but you can't create a plane. But if I give you 3 non-collinear points, so they're not all on the same line, then that's sufficient to define a plane, right? And we're going to do a question like that today as well. If I give you 2 intersecting lines, that's also enough to define a plane. And the other one is 2 parallel and non-coincident lines as well. So 2 intersecting lines or 2 parallel but non. So remember, the word non-coincident came up yesterday, and I believe I defined it then as being lines that are not sort of sitting on top of each other. That would be a coincident line. But non-coincident lines mean they're 2 separate. They could be parallel, but they're non-coincident lines. Okay, so 4 ways that you can define a plane. We're going to be doing some of them today. All right, let's get to it. Example 1. Find the vector equation of the plane containing the points. So they give you the point 3 minus 2, 7. And then contain the independent direction vector. And they give you the independent direction vector as this thing here. So these are 2 independent vectors. So 2 direction vectors that you can combine along with this point to create the equation of a plane. Use the equation to generate 2 other points on the plane. So once you've come up with an equation to represent the plane, then give us some points on the plane, right? That seems pretty reasonable. Let me just take you back again to what the different ways in which you could define a plane are. So we have a line and a point that's not on the line, right? We can have, as it says, 2 intersecting lines. So what we're giving you here is giving you a point, we're giving you 2 direction vectors to come up with the equation of the line. Well, it's very similar to what we did yesterday, except that now we're going to have 2 direction vectors and 2 parameters. So I can define my line as follows. As I'm going to use R. I've been using R all along. I'll continue using R. Of course, I can sometimes just, well, actually, R is probably a good enough way to do it. So R is equal to the point 3 minus 2, 7. And I'm going to be adding on to that. I'll use M and T. M, so that's one of the scalars that I'm going to be multiplying these other vectors by. So 1 minus 2, 1. And T times minus 3, 1, and 4. Okay? So that is the equation of a plane. I can't just define the plane as I did yesterday with just one of these direction vectors. I'm using 2 direction vectors this time and a point that's on that plane. So there is my equation, right? And that's a vector equation. So I use the equation to generate 2 other points on the plane. So how do you think I would generate 2 points on the plane? What do you think I would have to do? I'm going to be looking at you now for some help with coming up with answers like those. What do you think I would need to do? Choose a random value for the M and the T. Absolutely. So let's say that M is equal. I'm just going to make something up. Clearly, I'm just going to make something up. I'll use a very simple number like 1 and I'll use a t-value of, let's say, -1. Okay, let's just make it easy for all of us. So my x value would be equal to the 3 plus 1 times 1 plus minus 1 times 3. Right? So what I've done is I've chosen two values for m and for t, as you just saw Darius say. Can m be equal to t? Sure. There's no reason why you can't have equal values for m and for t. Can it be equal to 0? Yeah, because if they were equal to 0, good questions, both good questions, then you'd just be ending up with this point, which we said was on the plane, right? Isn't it -3? It is, yes, it is -3. Thank you, Alex. It is -3. All right. So remember that if I were to, shouldn't it be, yes, yeah, thank you. Yes, Alex was pointing that out to me. So I know I messed up on that. Thank you for both of you to help me out with that. So yeah, if you were to make them both 0, which is certainly a point on the plane, then you just end up with these being blanked out. And then you'd end up with just simply the one point that we said was on the plane. So yes, that would certainly give us a point that's on the plane as well. But that, of course, is just one of several points that are on the plane. So the point that we're talking about here would be equal to, what is this? 3 plus 1, which is 4, plus 3, which is 7, I guess. So that's my x value on the for this particular point. And how do you get the t equals -1 again? I just made it up. Okay. We didn't look at the comment from Dari. He says choose random values for m and for t. Right? So you can just simply choose values that you want. As long as you're consistent with those values, then you'll end up with a point that's on the plane. So I chose easy numbers to work with. I chose 1 and I chose -1. So 3 plus the 1 plus the -1 times the 3 gives us the 7. So that's your x value. And in your y value, very simply, it asks us to generate two other points. I'm just going to do one because once I've done one, I'm sure you can figure out how to do another one. So it's -2 plus -2. I'm going to multiply that by 1. So it's just going to give me -2 plus -1 times 4. Okay. And that's going to give me -4 -8. And then my z value, I think I did that right. -2 -2, that's -4. And then another -4 -8. And then my z value, again, would just be equal to 7 plus, this looks like 1 again, plus this looks like -4. Okay. And that would be equal to 4. So this is, yes. Oh, hang on. For the y, so it's the 7 plus the 1, and then -1 times the 4 should give me -4. So what's wrong with that? Isn't it 1, not 4 for y? Let's see now. So it's 7 plus 1, and then -1 is the t value. So -1 times 4 is -4. What am I doing wrong? Y is 1. Y is 1. The z. Okay. So you're saying my y was wrong then? Is that what you're saying? -2 plus -2 plus -1 times 4. Okay, so that's good for minus. Oh, yeah. Okay, fine. Yeah. Yes, folks, at some point I need to get it right. At some point I need to get it right. Let's try that again. So you're looking at -1 times 1. Yeah. So that makes this wrong as well. Thank you. That shows me that you guys are really paying attention. I'm not doing this on purpose. Not doing this on purpose at all. So let's try that again. -2. 1 times that's another -2. And then 1 times the 1, which is, so -1 times 1, which is that. So that would be -5. I certainly wouldn't get full marks on that question. All right. So how about the z? Let's see if I got the z right. So that's 7 plus 1 minus 4, which should be 4. All right. So am I okay now, folks? Can you give me a thumbs up or a thumbs down on that? Thank you, Asia. Okay, so it looks like I got my stuff together now. Okay, so here's my point, or the point that's on the line. It would be 7 minus 5 and 4 for your X, Y, and your Z. And thank you all for making sure that I was kept honest on that question. So that's just one point, but the question asked for two. But really, I mean, based on how badly I did the first one, I don't think I want to try another one. All right, so there you go. So that's one point that's on the line, and you could easily find another one by just changing your M and your T, or just changing one of them. Just changing the M and not the T. Doesn't matter. All right. Okay, so let's get to number 2. And I'm going to be asking you for some help as we go along. I'm going to be asking you, what do you think would be the way to get the answer that we're looking for? Because once you have the hang of it, once you understand that you are looking for vector equations that look like, and I'll go back to this, that look like this. So you have an X, a Y, and a Z, okay? And you have 2 direction vectors. Then once you understand that, then you're ready to write all the other questions. So here's the first one. Here's the second one. Find a vector and parametric. Oh, did it ask for parametric, by the way? Oh, just ask for vector equation. So vector and parametric equations for the plane containing the points, and they give us that point and the line. So they give us a line this time, and the line is just simply this. So all the equations of planes have 1 point and 2 direction vectors. That's right, Zia. That's exactly right. Okay, that's exactly right. So let's get back to this question now. Thank you for asking that, by the way. That's a good question to clarify. So find the vector and parametric equations for the plane that contains, I give you a point and I give you a line. Remember, that's enough to define a plane. So here's a direction, here's a line, right? And we know how the line equations look. You get a point and you get one parameter along with a direction vector. So here's the equation of a line, right? That's an equation of a line. And here is one other point. You couldn't just create a plane if you just had one point. That's crazy. You couldn't just create a plane if you just had a line. That's also crazy. So you're saying, Zia, that we can use head and tail of the 2 points. Absolutely. Absolutely. So what you're saying is that we know 2 points on the line. So here's 1 point right here. Here's another point that's on the line. So is it equal to the point you're saying? Let's see. So you're okay. So we need another direction vector, and it seems like we can get one because we have a second point that's on that line. So you're right. We have the 2 points, right? The 3, 4 minus 1 is a point, and this is also a point on the line. This is just a direction vector. But if we have another direction vector, then that means that we'll have the equation of a line, or it could come up with the equation of a plane. So let's go ahead and get that second direction vector. And when you say head minus tail, it doesn't matter whether it's head minus tail or tail minus head in this case, because the direction of that vector really could be reversed by just simply changing the parameter from positive to negative. So we can just take it either way. So what I'll do is I will go with the 3, 4, minus 4, 1. I'm going to subtract from that the 1, minus 2, and 2. Right? I'll subtract it in that order. So that would give me 2. Let's see, that's minus 4 plus 2, which is minus 2. And then 1 minus 2 is minus 1. Let me double check that. 3 minus 1 is 2. Minus 4 plus 2 is minus 2. And 1 minus 2 is minus 1. So there you go. What did I do wrong now? Minus 1, not minus 2. Minus, isn't it minus 1? Oh, from up here it was minus 1. Let me see. 3 minus 4, 1. And 1. Oh, sorry, 1 minus 1 and 2. Where did I get this from? Where did I get that from? All right, let's fix it. Yes, go ahead. Yeah. Because remember, you're multiplying it by a parameter, which if you just made that parameter the opposite sign, because remember, you're trying to get every single point on the plane. or you have access to every single point on the plane. So by just simply changing the parameter from being positive negative, you get another set of points. You can get all the points by just changing that parameter. That this number that's in front of this parameter here, right? This 3, 0, minus 2, this could become minus 3, 0, positive 2, because I just simply changed that t to a minus 1. Does that make sense? Right? Because just changing this will mean I can get to any, if we go back to the line for just a minute, this is the equation of a line right here. The equation of the line is telling you that you can reach to any point along that line by just simply changing the value of the t, right? So if that t was a minus 1, then this direction would become minus 3, 0, and positive 2. So no, it doesn't matter which way you do it, because changing the t's, or what you're trying to do is just make sure you can access any point that's on that plane or on that line. So let me go back and try and fix this now. Let me go back and see if 3 minus 4, 1. Okay, I copied that down right. 1 minus 1, 2. 1 minus 1, 2. Okay, fine. All right, let's see if we can fix this now. 3 minus 1 is 2. Minus 4 plus 1 is minus 3. And 1 minus 2 is minus 1. Okay, so I think I got it. Oh, but hold on. No. Yeah, you know what? I keep looking at this thing over here when I'm trying to get my numbers. So it's 1 minus 1, 2, and 3 minus 4, 1. Okay, I think we're good now. I think we're good now. So anyway, this represents my second direction vector. So now I'm ready to write my equation of the plane. So it's x, y, z is equal to m times the 2 minus 3 minus 1 plus t times 3, 0, minus 2. Okay, and can you use any of the 2 points? Yes, yes, as long as you use a point that's on the plane. It's just like when we were doing the lines yesterday. Again, when we get to the Cartesian, this is not the standard form. So you're going to find that because it's not the standard form, then you can create that equation in a number of ways. Don't we need to put the point in the equation? Yes, we do. Yes, we do. I don't know why I'm making all these mistakes today. Let's try and fix that. I do need to put the point in the equation. All right, so let me take a deep breath and try this again. I'm going to put r this time. And I'll choose the point that was there before. Plus m times this vector 2 minus 3 minus 1 plus t times the 3, 0, minus 2. Okay. Yes, yeah, we do need to put the point in, and I've just put that point in. Absolutely. That was an oversight on my part. Okay, let's see if we can keep this error-free for the rest of the class. Okay, the vector and parametric equation. So we know how the parametric equations look at this point. Our x is equal to the 3 plus 2m, excuse me, plus 3t, or y. Let me check that. 3 plus 2m plus 3t, right? Or y is equal to the minus 4 minus 3m, and then there's no t on that one. And then the z is equal to the 1, and then that's minus m and minus 2t. Okay? All right, I think I have managed to finally get that right. So I have the vector equation. That's the first one that we put in, right? So the vector equation would be this one here. And then I have my 3 parametric equations, which are these things here. And by the way, t and m is an element of r, right? Something I should have mentioned all along. Okay, so I think we're good with that. We're going to move on to the next question. Again, I'm going to be looking to you for sort of prompting me along on this, right? How did this not get erased? Let me do that quickly. Okay, so question B, part B of the same question is, do both of these points lie in the plane determined by the equations in part A? Any suggestions as to how I could determine whether any of these points lies on the plane? So we'll take the 3, 2, 1 as an example. Solve for T and M first. Okay. Okay. So let's start off with the points 3, 2, and 1. So let's go back and look at what the x is. The x is 3 plus 2m plus 3t. All right, so let's write that down. In fact, what I should probably do is maybe the thing I just erased, I should have left there. 3 plus 3t plus 2m. Is it the same as what we have here? Minus 4 minus 3m. Minus 4 minus 3m and 1 minus m minus 2t. Yeah, so it's the same thing. So it's probably not a bad idea that we have that, that I didn't erase what was there before. Okay, so I'm going to keep that there as a reference. And let us now start off with the x. And I'll go back to black, by the way. Let's start off with the x. And we know that 3 is the value of x in this one. So 3 is equal to 3 plus 3t plus 2m. But I can't solve that, can I? I can't solve for m and t at the same time. So what am I going to do then? Any suggestions as to how I could fix this? I can't solve that equation right now. Right? Can we agree on that? That's not solvable. Right? I can't solve for m and t. Sorry? Okay, but how am I going to eliminate if I only have one equation? Okay, so we need another point. Now, luckily for us, in this particular case, if we had just gone straight to the y, we could have solved for y, right? And I see some people saying that. I can solve for this one, it just has a y and an m in it. So in some cases, we will need two equations, but in this case, we actually don't, because we can solve for y in the second equation. Sorry, the m I should say in the second equation, because there's only really going to be one unknown. So we're gonna leave this on hold for now, right? We can come back to this a little later on. The fact is that yes, Irfan, go. Correct. Correct. Yes. Yes. Of course. So the point is that so in this case we have a bit of a shortcut because one of the equations doesn't have a t in it. So we can just solve for m right away. But there are occasions, and we may find that, maybe I should do this without using the y. Maybe I should go ahead and try to do this with z and see what happens. Maybe we should do that because in this case, there's a shortcut. In this case, we can find what m is right away by putting the value of y into this one, right? And we can solve for m, and then we could use that to solve for t in the other equation. But what if we had to solve for both at the same time, which is the point that a lot of you are making? Right? So if you're game, if you feel like you're up to it, why don't we skip the y, which is a shortcut one? If we didn't have one which only had one variable, maybe we can just go ahead and figure it out for z, and then we would look at it as being, so you can use z and isolate for m, but y is quicker. It is absolutely, Alex. In this case, y would be. I tell you what we'll do. Let's do this one. Let's do this one with a shortcut, and then the next one will be a little bit more thorough, and we'll do a real linear system. Okay, so let's go with the y. So in this case, we're saying that 2, which is the y value for the first point, is equal to minus 4 minus 3m. Okay, and I'm going to add that to the other side to give so hopefully everybody is okay with that. And then I'm going to add the 4 on the other side, which gives me 6 is equal to minus 3m, which means that m, it's a funny looking m, which means that m is equal to minus 2. Okay, and now we can come back to the first equation, the one that's in the box, and we should be able to solve for our t. So I'm going to go back to that now and say that 3 is equal to 3 plus 3t plus 2 times minus 2. Okay, and let's see now. Let's set this equal to 0 is equal to 3t minus 4. So therefore, t should be equal to 4 over 3. Okay, hopefully we can all agree on that. All right, so those are the two values that we are hoping will work for the other point that's in here. So we know that for 3 and for 2, that works fine. But does it work for the point z? Point z is 1. So we're going to put 1 in now and see what happens. So 1 is equal to 1 minus 2 times the t value said was 4 over 3 plus the, minus the m value, which we said was minus 2. And this isn't looking very promising right now, right? If you are following along with me. This side will need to be equal to 1. So 1 is equal to 1 minus 8 over 3 plus 2. And I don't see how this is going to work out at all. So I'm going to get 2 plus 1, which is 3. And 3 minus 8 over 3 cannot be equal to 1. So it does mean that we're going to have to abandon that first point. That this point we're going to conclude is not on the plane. Okay? Let's see if we have better luck with the second point. The second point is 0, minus 13, and 4. Okay? So with that combination, actually, what I'm going to do is I'm going to copy this box onto another page so we can use it. Yes, Irfan. Go ahead. You got it. Okay. So let's paste that over here. And then the point that we're trying to get this time is the 0 minus 13, 4. 0 minus 13, 4. So 0 minus 13 and 4. All right. Let's see how this one works out. So we're saying that 0, that's my x value, is equal to 3. Now, again, we could use a shortcut of getting the y. Let's just be honest about that. We could use that shortcut. But let's just pretend that we don't have that available to us, that every single one of these parameters in the parametric form was 2 variables. So I'm going to use the x and the z and see if we can solve for it, because I want you to get the practice doing it that way as well. So let's say that 3 is equal to, 0 is equal to 3 plus 3t plus 2m, right? And of course, we can rearrange that to give us 3t plus 2m is equal to minus 3. And then we're going to use, like I said, I'm going to use a z value next. So I'm going to say 4 is equal to 1 minus 2t minus m. And I believe we can write that as m plus 2t is equal to, adding that to that side, equal to minus 3. Let's see if that works. I'm just trying to make sure that that works. So bring those on that side, which makes that equal to positive m, positive t. 1 minus 4 is equal to minus 3. Okay. So I don't know how you have solved these in the past. Let me just sort of get a little reading from the class. Do you mostly use elimination or do you mostly use substitution? What is it that people find most comfortable? Substitution. Okay, so in that case, I'll say that m is equal to minus 3 minus 2t. I'll go with Darius' choice. Somebody said, all right, elimination is easier with bigger coefficients. It can be. Well, I'll just continue with this since we started this. So m is equal to minus 3 minus 2t. So then I'm going to make the substitution. I'm going to come over here. I know this is kind of going back and forth, but we'll do what we can. So 3t plus 2 times minus 3 minus 2t is equal to minus 3. All right, let me just make sure I got that right. 3t plus 2 times the m, which is that, is equal to minus 3. So 3t minus 6 minus 4t is equal to minus 3. I think that's good. Minus 6 minus 4t is equal to 3. And then I'm going to put the minus 3 on that side, which gives me positive 3. And this looks like minus t to me. 3 minus 4t is equal to positive 3 minus 6 plus that. So that means that t is equal to minus 3. All right, and therefore m is equal to minus 3 minus 2 times minus 3. So that's minus 3 plus 6, which is equal to positive 3. So positive 3 and negative 3. Solution is easier with bigger coefficients. Okay, I'm looking at the comments there. So our test now is we've worked with 0 and 4. We're going to see if the minus 13 is going to work for us now with the y. So y, sorry, minus 13, right? So we're going to go back to the minus 13 now. Sorry, what am I looking for now? Z, yeah, Z is, sorry, y. Y is minus 13. So minus 13 should be equal to minus 4 minus 3 times 3 times the m, and the m was positive 3. So this checks out. All right. So in this case, this point, this second point that we had is in fact online. That's a bit of work. And the truth is that the shortcut would have been the thing to do if I'm on a test and I know that that's going to get me there faster. But I was just showing you, what if we didn't have a shortcut? What if we had to do this without the option of a shortcut and we had to solve a linear system? I'm just saying that that's sometimes possible. In this case, it wasn't really necessary, but there you go. So one point was not. All right, let's move on. Let's move on. Example 3. And again, I'm going to look to the class to see if you can give me your best guess as to how we would approach this. So what is the x-intercept of the following plane? Where does this, and this plane, if you think about this flat surface, is likely going to, unless it is exactly on the x-axis, right, it's probably going to cut through the x-axis at some point, right? And that point probably has some coordinates. And that's what we're trying to do here. We're trying to figure out, just try to think of 3 space right now. Try to think of the 3 axes, one going up and one coming out to the page and one going left and right. And there's a plane that's going to slice through that x-axis and probably have some unique point where it slices through the x-axis, right? So what do you think, folks? What would be a good way for us to find the coordinates of that x? What does the pi mean? Oh, that's what they generally use to represent the equation of a plane. I use it sometimes, but very rarely. When you see pi in the concept of in vectors, it's usually referring to the equation of a plane. So pi 1 just means the first plane, because you might have more than one plane. So the pi subscript 1 would be the first plane. But yeah, they use pi to represent planes in vector terminology there. So that's all it is. That's a good question. I forgot to mention that. So whereas I've been using R and other things, pi is what they normally use. Anyway, let's get back to this. X-intercept. How do we get the x-intercept? Any suggestions on that? All right. Why do you put y equals 0? Yeah, you not only put y equals 0, think about what every single point on the x-axis would be. Every single point on the x-axis has a y coordinate of 0 and a z coordinate. Just think of where that x-axis is. This x-axis, remember, is the one that is running out of the page, right? As you take any point on that axis, you haven't moved along the z-axis, you haven't moved along the y-axis, so the other 2 coordinates would be 0. So yes, we're going to make it exactly what Quinn and Alex and Daria are saying. It's both the x and the y that we're going to set equal to 0. Okay, so we're saying that we want to know where what is the y value when the when the z is equal to, and remember, I just remind you now that this has parametric forms, which is that your x is equal to the 3 plus, I don't use S generally because although you see S in the question, I use M and T because my S's look like 5s. So it's probably not a good idea. So it's equal to the M 4, 5, sorry, what am I doing? 4 times, let me erase that. So 3 times, and it's 4 times M plus or minus 3 times T. And my Z, of course, is equal to, I'm just putting in the parametric form. And my Z would be equal to the 2 plus the 5M. And I just call this thing M instead of T, okay, instead of S. The 5M, and then the plus 7T. And that's my Y actually. And my Z is equal to the 5 plus the, or in this case, minus the M plus the 4T. All right? Yeah, it should be Y. Thank you. It just should be Y. Thank you all very much. Okay, so what are we saying now? We're saying that we want the Y value to be equal to 0 and the Z value to be equal to 0. Okay, so what we're going to do is we're going to set this equal to 0 and set this equal to 0. So the X value would be what we're going to get from calculating what these are when your X is equal to 0. Sorry, when your Y and your Z are both equal to 0. So we're going to have to go ahead and solve another linear system. Unfortunately, that's just the way that goes. So I'm going to go ahead and say, okay, so that's 5M plus 7T is equal to minus 2, and minus M plus 4T is equal to minus 5. Okay. Somehow I think I did something else wrong here. So that's 5M plus 7T, and that would be a Z of 5 minus M plus 4. Looks like I'm good there. All right. Okay, I'm actually going to use, since some people do like elimination, I'm going to go ahead and use elimination this time. And the only way that's going to work is if I multiply through the second equation by maybe 5. All right. So that's going to give me, so the top is still 5M plus 7T is equal to minus 2. But now my bottom equation is going to be minus 5M. I'm multiplying everything by 5, by the way. So that's plus 20T is equal to minus 25. Okay, all I'm doing is I'm just simply multiplying everything in the bottom equation by 5. And instead of adding, instead of subtracting, I'm going to add these two equations together. So that's because they have opposite signs here. So 27T is equal to minus 27. All right. I'm just adding the t's and adding the constant on the end. So t is equal to minus 1. And because I now know what t is, it's easy enough for me to find what m is. So I'll go back and plug that into one of these equations. So 5m plus 7 times minus 1 is equal to minus 2. So that means that 5m minus 7 is equal to minus 2. Therefore, 5m is equal to 5. And therefore, m is equal to 1. All right, so now I have both my m and my t. I can go back up now and look for my x value by putting in those values of m and t. So my x is now equal to 3 plus 4 times my m of 1 minus 3 times my t. And my t we said was minus 1. So that looks to me like we're getting 3 plus 4 plus 3, so that's 10. All right, so here is my point of intersection. So my POI, where it intersects with the x-axis, is 10, 0, 0. That point we know is on the line, and it has the required y and z coordinates of 0, and my x coordinate in that case would just simply be 10. All right. Okay, so far so good, hopefully. Let's move on. Determine if these points are coplanar. Uh-oh. That's probably the most challenging thing we've been asked to do so far. Just given a bunch of points. And there are 4 points, by the way, right? 4 points. We're asked to show, or to determine, sorry, I should say determine, that these points are coplanar. Any suggestions on how we might be able to do that? No, they don't say that they form like a rectangle or anything like that. You know, we don't have that information. Find plane using A and B, and then see if C and D lie on the same plane. Maybe first come up with an equation of the plane. Okay. Now we can check another point to see if that other point is on the plane as well. Good point. I like both points that Daria and Zia came up with. So how do we start the process then? Give me a way that we can start the process. So what do we do with the points in order to come up with the equation of the plane? That's what we need to do. Head minus tail of 2 points. Now, in this case, we have to be careful when we're coming up with the head and the tail, because the tail and the head have to be, we have to put 2 tails together. Okay, so we can take, perhaps, I'll just put it to you this way. Let's say this is A and this is B, and let's say this is C over here, right? If we're going to put vectors tail to tail, now in this case, I would say that the order will matter in how you create those vectors. I'm going to use A, B, and C as 3 of those points. A has whatever the coordinates are, B has whatever the coordinates are, and C has whatever the coordinates are. We have to take AB and AC, so in that order. So we're going to take the AB vector and the AC vector. Now we're assuming right now, now it's always possible to put lines like these together, right? It's always possible. Why do we need vectors? Can we just use AB? Well, but how many direction vectors did we have here when we were putting these equations together before? How many direction vectors did we have? You remember from O2? Okay, so that means that if we just had one direction vector, then we could get the equation of a line, but we're not looking for an equation of a line, we're looking for an equation of a plane. So we need 2 vectors, okay? And can we choose any 2 vectors from the given points? Yes, we can, right? Just make sure that at least 2 of those vectors are tail to tail when you're trying to come up with the direction vectors. Could you also do the add? Do add. A to D. Oh, yeah, sure. As long as, again, yes, we could. As long as you're going to take, if you're going to go A to D, then you have to go like A to C. Just make sure that there is at least one point, which is the common starting point for 2 of the vectors. Does that make sense? Because you want to put the vectors tail to tail when you're finding. Yeah, perfect. Okay. So we'll use the AB and the AC, but yes, we could have used the AD and maybe AC as well. We don't really care. It doesn't matter. So if I chose to use BC, you could use BD. Yes, Sharujan. Yes, absolutely. Absolutely. So it was B to C, then with B to D, or whatever you like. Just any combination of the vectors, as long as you put 2 of them tail to tail, and that's the only sort of restriction I would put on that. Okay. All right. So now that we've decided on this, hopefully we're all settled on these 2 vectors. So now we're therefore considering the 3 points A, B, and C. We're going to come up with 2 direction vectors for this magic to happen. So we're going to go B minus A first of all, and B minus A. So this is the AB vector here we're talking about. The AB vector would be equal to So that'd be 3 minus 4, which is minus 1. And that would be 2 minus 5, which is minus 3. And that would be 3 minus minus 1, which is 4. All right, let me double check that because I've not been doing so well today at all. I just maybe distracted by my new computer over here, which I'm playing with. But let me just focus in. Focus, Mr. Kamal. Focus. All right, so let's try this again. B minus A. So that's 3 minus 4, which is minus 1. 2 minus 5, which is minus 3. And 3 minus minus 1, which is 4. Perfect. All right, and then we have to find the AC vector now. And the AC vector, let's see now. So that's C minus A would be 5 minus 4, which is 1. That's 6 minus 5, which is also 1. And minus 3 minus negative 1, which is minus 2. Okay? All right, folks, you want to just sort of make sure that I haven't messed up again. And before I go any further, you always are so good at checking up on me on these things, and I do appreciate that. Let me check my numbers to myself. Minus 3 minus minus 1 should be minus 2. 6 minus 5. 5 minus 4. Yeah, so I think we're good. I think we're good. So now we're in a position to be able to write a vector equation. So here's our vector equation. Our vector equation, I'll use obviously one of these points for my vector equation. So, let me go at the fancy pi thing here that we just saw a while ago. That would be equal to, I'll use a 4, 5, 1 for no particular reason, right? Because we know that that's one point that's on this plane that we're creating. So I'll go 4, 5 minus 1 plus m times, I'll use the first one here, minus 1, minus 3, and 4, plus t times 1, 1, and minus 2. Okay. Should I write pi 2? Was there another one before? I mean, this is the only plane that we're dealing with here. So I just put pi. All right. If there's another one, then I'd probably put a pi 1 and a pi 2. Okay. But since there's only one, I decided to just put 1 for pi 1. Okay. Oh, wait. Sorry. Mix up with the other question. Yeah. No, it's a different question. Completely different question. All right. So the question now is, we have made these 3 points, and the truth is, any 3 points could be a plane. Okay? You just put 3 points in space and you would have a plane. The question though is the 4th point sitting on that plane? That's the issue. Okay? Now we just set point D. Yeah, see, point D lies on the plane. That's exactly right, Zia. That's exactly right. Now, if it does, then the points are coplanar. There's another way that we're going to do this in terms of coplanarity, but for now, let's just go with that method. So we took the 3 points that we had, and any 3 points could form a plane, and we created a plane from it. Now we're going to see if this 4th point lies on that plane. All right, so let's put our parameters together. So my x is equal to 4 minus m plus t. You know what? I'm just realizing that my pluses and my t's look very similar. So I should probably start using another letter, but since we've got accustomed to the t, we'll stick with the t. So plus t. So 4 minus m plus t. My y is equal to 5 minus 3m and plus t again. And my z is equal to minus 1 plus 4m minus 2t. Okay, so those are my parameters. So here's a case where we don't have a shortcut. We're just going to have to slug along and solve for m and t using 2 at a time and then checking the third. So here we go. Starting off with the minus 8. So we're saying that minus 8 is my x value is equal to 4 minus m plus t. And we're hoping that 6 is equal to 5 minus 3m also plus t. Actually, we're going to be fortunate on this one, right? Because the t's have the same coefficient. So that's pretty helpful, actually. Okay, let me rewrite the top equation as minus 12 is equal to minus m plus t, right? I just took the 4 and brought it over. And then this one is going to be 1 is equal to minus 3m also plus t. Okay, so let me just subtract these equations from each other this time. So minus m plus, so minus 1 plus 3 would be minus 2m. All right. And then minus 12 minus 1 is, oh, that's awkward, minus 13. That's not a nice number. Did I make a mistake here? Let's see. Let's check up here first. 4 minus m plus t. That's good. So that's 6 minus 5 is 1. Minus 3m plus t. Subtract, you get that. You get some. Okay, looks like it's good. So unfortunately, it's not a nice number to work with, but then so be it. So that means that m is equal to 13 over 2. Okay. So now we have to find what our t is. And our t, let's see now, using this equation here, I'll come over here. I know I keep sort of jumping back and forth all over the page here. So minus 12 is equal to minus m, which is minus 13 over 2 plus t. Okay, I'm just substituting the value of m into, okay, let's just see, I got, no, it's actually plus 13 over 2. No, minus 13 over 2 plus t, yeah. So t is equal to minus 12 plus 13 over 2. Uh-oh, what did I do first now? Shouldn't it be 2m? Okay, let's see. Minus 12 is equal to minus m plus t. So minus 13 over 2. So what did I do wrong here now? Sorry. Shouldn't it be 2m? Yeah, I did. As in, oh, you mean positive 2m. Yeah. You're right. You're absolutely right. So let's fix that. So that makes this thing become negative then, positive 2m. Sorry, folks. I am apologizing 10 times over. Minus, so that's positive. Yeah. So that would be minus 13 over 2 in that case. Yeah, you're right. Yeah. Okay, so let's come back over here. Let's fix this. This is now going to become positive 13 over 2 because I'm now putting it into this equation. Minus 12 minus m, and my m was already minus, so it's positive 13 over 2 plus t. So it's minus 12 minus 13 over 2. Okay. So t, if I put this as being minus 24 over 2 minus 13 over 2 works out to be minus 37 over 2. Okay. All right, so we have our t, we have our m. We're just going to hope now that the third point is going to behave, which is the 10 is what so we use this for the 8 and for the minus 8 and for the minus 8 and 6. Let's see what happens with the 10 now. So for the 10, we're saying that z should be, and that z is 10, by the way. Should be equal to minus 1 plus 4 times the m, which was minus 13 over 2, minus 2 times minus 37 over 2. Okay, so this looks like minus 1, 2 into that is 2, so that would be minus 26. Well, that can't be, if they're all negatives, that's not going to work. Minus 26. And this is going, oh, this is going to be plus 37. Okay, no, that's not right. 26 plus 37. Nope, nope, nope. Something else is wrong here, folks. Because I believe they're supposed to be coplanar. Oh, but then when you add them up, you're supposed to get, was that 37? Well, minus 27. Yeah, okay. So that is positive 10 actually. Yeah, it is. There you go.